Life support, good. Depth, 109 or 28 meters. At bottom, repeat.
7 miles beneath the Pacific, in the Mariana Trench's Challenger Deep, lies what was supposed to be the quietest place on Earth, a crushing, lightless abyss. In 2015, NOAA scientists lowered a titanium hydrophone into the darkness, expecting near silence. Instead, they captured sounds that stunned even veteran oceanographers: groans, metallic twangs, and low rumbles that shouldn't exist at such depths. How can the deepest place on Earth be this loud? And what was really making those sounds? The mission to the bottom of the world. What exactly did that titanium microphone capture? The answer hit the team like cold water. It wasn't just noise. It was proof that the abyss is listening to the entire planet. In July 2015, NOAA scientists set out to do something that still sounds unreal in conversation: record audio from the deepest point in the ocean. Down in Challenger Deep, almost 7 miles below the surface, where pressure climbs to roughly 16,000 pounds per square inch, and the ocean behaves like a giant hydraulic press. This wasn't a casual drop-and-pray experiment. The mission was led by NOAA researcher Robert Giac and his team, and they treated the trench like space. Because that's what it is, an alien environment on Earth. They built a ceramic hydrophone, then locked it inside a titanium pressure housing so it wouldn't implode on the way down. Picture a microphone wearing armor, not for sharks, but for physics. And then they released it. The descent takes time, and that weight messes with your head. Up top, the ocean looks calm, like it's pretending. Down below, the hydrophone is sinking through darkness so complete it feels like the world has ended. No sunlight, no reference points, just water and weight. Here's the part people miss. Scientists don't panic because they want a good story. They panic when reality breaks the rules they rely on. So when the first data started coming back, and the recording sounded loud, chaotic, and strangely alive, the team had to ask the scary question: is this the ocean? Or is this the equipment failing? Because they weren't hearing a quiet trench. They were hearing a trench with a soundtrack, low rumbles that felt like the earth clearing its throat, sharp pings like distant metal being tapped, long groans that didn't sound like one creature, but like pressure itself, complaining. And storms on the surface were showing up down here like they were right next to the mic. Think about that. A typhoon can be raging 7 miles above you, and you still hear it in the deepest trench. That's not just creepy. That's a clue. The ocean isn't a blanket that muffles the world. In some ways, it's a highway for sound. It carries vibrations across huge distances, then funnels them into places we assumed were sealed off. If you were a scientist staring at that waveform for the first time, would you trust your ears? Or would you assume the machine was broken? Because once you accept the data is real, the implications get weird fast. The trench isn't a dead zone. It's a global listening post, collecting earthquakes, storms, ship traffic, and who knows what else in one dark archive. And buried inside that rumbling, one sound refused to blend in. A 5-part metallic twang, precise and punchy, almost like something engineered. Not a roar, not a whale call, a twang. And that's where the real questions begin right now. The biotwang and the AI revelation. That 5-part metallic twang didn't just stand out. It challenged the whole mental map of what scientists thought belonged near the Mariana Trench, because it sounded engineered, clean, repeatable, almost like a signal. And for a while, the uncomfortable thought in the room was not new creature. It was, did we just bump into something human-made down where humans should not be? This is where the deep ocean legend called the biotwang enters the story. The sound was first picked up in 2014 in the Mariana region, and it instantly became the holy grail of underwater anomalies. Not because it was loud, not because it was scary, but because it was weirdly structured. The call lasts about 3.5 seconds, and it's built like a little audio puzzle box. It starts with a low moan that slides downward, roughly from about 44 Hz to 30 Hz. Then it snaps into those higher, metallic pieces that climb all the way up toward about 8,000 Hz. A single sound that lives in both the earthquake zone and the electronic squeal zone at the same time. That is exactly why people side-eyed it. Because if you're an ocean acoustics researcher, you're used to whale songs, ship engines, storms, and earthquakes. You are not used to a call that feels like it was designed by an audio engineer. So the early fear made sense. What if this was some secret underwater technology? Some unknown facility? Some equipment is doing something it should not be doing? Not in a conspiracy way, but in a we need to rule out the impossible before we publish anything way. And the panic wasn't just about the sound, it was about the location. Researchers believed the call came from a baleen whale, but they could not lock a species to it at first because there was no visual confirmation. That gap is everything in science. No eyes, no certainty. Then came the breakthrough, and it's the kind that feels like the future arriving early. In 2018, during a NOAA visual and acoustic survey in the Mariana archipelago, teams spotted multiple groups of bride's whales. And in 9 out of 10 groups, they recorded biotwangs at the same time. That's not a coincidence. That's the ocean finally pointing at the culprit. But the real, fresh insight landed in 2024, when NOAA scientists teamed up with Google AI and used machine learning to sift through massive archives of underwater audio, helping map when and where these calls appear across the Pacific. In other words, AI helped turn the biotwang from a creepy clip into a searchable language pattern. And here's the part that flips the vibe. Bride's whales are not the classic deep trench celebrities people imagine. They're understudied, their movements are still being mapped, and the biotwang shows up seasonally in ways that suggest migration through the region, including the Mariana area and even farther east at Wake Island. So that sound didn't just identify a whale, it rewrote where scientists think that the whale population travels. Can you imagine a whale calling into the darkest hole on Earth, basically playing Marco Polo in a place that was supposed to be silent? Because once you accept that, the ocean feels smaller and more connected. The trench isn't hiding life from us, it's broadcasting it. But now the story gets heavier, because some of the strangest noises down there do not come from animals at all. What happens when the sound isn't alive, but geological, like the Earth's crust shifting its shoulders in the dark? When the Earth screams. The scary part about the biotwang isn't just that a whale made something that sounded mechanical. It's what it taught the scientists watching the data scroll by. The deep ocean doesn't just hide secrets, it carries them. And once you realize that, the next monster sound stops feeling like a creature and starts feeling like the planet itself trying to talk. Because sometimes the sound isn't alive. Sometimes it's the Earth. Out in the Pacific, NOAA's listening networks have been picking up a strange signal since 1991. They call it upsweep, and the name sounds harmless until you hear what it does. It's not one clean beep. It's a repeating, rising tone that shows up in trains, in cycles, like the ocean is running a siren test in the middle of nowhere. Scientists think it's linked to underwater volcanic or seismic activity, and it even changes with the seasons, peaking around spring and fall like a strange ocean heartbeat. Here's why that matters for our story. Upsweep proves the ocean can deliver a sound across an entire ocean basin, not a few miles, not over the horizon. We're talking distances that make your brain hesitate. And the mechanism is basically a natural sound tunnel called the SOFAR channel, short for sound fixing and ranging. The ocean has layers where sound speed changes with temperature and pressure, and in that special zone, low-frequency sounds can get trapped and guided, traveling hundreds or even thousands of miles without losing much power. So when we say Challenger Deep is listening, we mean it literally. Think of the trench like a stethoscope pressed against the planet's chest. It's not always the source of the noise. It's the collector. It's the recorder. It's the place where the ocean funnels the world's vibrations into one dark archive. That's why, during the 2015 hydrophone deployment at Challenger Deep, the recordings didn't just grab mysterious twangs and distant whale calls. They also captured something that makes the whole silent abyss myth fall apart: a magnitude 5.0 earthquake in the nearby ocean crust. And the audio doesn't feel like a news headline. It feels physical, like a low, rolling pressure wave that turns into a roar. A quake that might have happened far enough away to be distant still hits the trench like a punch, because sound doesn't behave down there the way we imagine it up here. And that's where the so-called panic starts making sense. Not horror movie panic, technical panic, scientific panic. The kind that happens when your equipment is doing its job so well that it becomes unsettling. The team expected the deepest point on Earth to be quiet, a place insulated from the surface world. But the hydrophone kept catching signals from above and beyond. A typhoon overhead sounding closer than it should, ship traffic leaking into the abyss, seismic groans arriving like unwanted voicemails from the crust. It's the most uncomfortable twist. The deepest trench is not a sanctuary. It's an amplifier. So let me ask you two things, because this is where the story gets personal. If the Earth is constantly groaning beneath us, why do we only notice when it's too late? And have you ever felt a vibration in your chest that you couldn't explain, like your body noticed something before your brain could name it? Because down here, that's the default. And once you accept that whales and earthquakes can impersonate alien signals, you start looking at the greatest ocean sound legends differently. Which brings us to the next one. If whales and tectonic shifts explain the groans, what about the bloop? A sound so powerful it was picked up by sensors thousands of miles apart. Bloop, Julia, and the ice. And that's the twist nobody expects. Once you learn the trench can carry sound like a global speaker system, the monster noises start sounding less like teeth and more like the planet cracking its knuckles in the dark. Let's talk about the internet's two favorite boogeymen, the bloop and Julia. Back in 1997, NOAA's hydrophones picked up a massive, ultra-low frequency sound that rose in pitch over about a minute, loud enough to be detected across sensors thousands of miles apart. People heard that and immediately opened the Sea Monster folder in their brains. It got nicknamed the bloop, and the myth took off because the signal was powerful, strange, and came from a remote patch of the Southern Ocean. The scary part was not just the sound, it was the scale. If it was an animal, it would have had to be absurdly loud, louder than anything we had on record. But then NOAA did what science does best. It stayed stubborn and checked the boring explanations until one of them stopped being boring. Over time, researchers matched the bloop's signature to icequakes, which are the sounds made when huge ice masses crack, fracture, carve, and sometimes scrape the seafloor. Ice is not quiet. It screams, it grinds, it snaps, and underwater those low frequencies travel like they've got a passport. And then there's Julia, recorded on March 1st, 1999. This one lasted around 2 minutes and 43 seconds, and got its nickname because, to a human ear, it weirdly resembles a voice. That's catnip for the internet. People went straight to aliens, secret bases, and, yes, the usual tentacled fan fiction. But NOAA's analysis points to something even more unsettling in a real-world way. a large iceberg grounding off Antarctica, dragging and groaning against the seafloor. The source region was narrowed to an area between the Bransfield Straits and Cape Adare. So here's the debunk that still keeps the goosebumps. The most terrifying sounds aren't biological. They're geological and cryogenic. They're ice and rock under stress, releasing energy through cracks you cannot see. And because the ocean is such a good sound highway, those cracks don't stay local. They travel. They echo. They show up on instruments far away, like the planet is sending push notifications. Now, quick reality check, because I know somebody is thinking, okay, but what about the creatures? This is where history gets funny. In 1960, when Jacques Piccard and Don Walsh reached Challenger Deep in the Trieste, one early report described seeing something like a flatfish. That story became a legend because it sounds impossible at that depth. But modern deep-sea biology has gotten way more detailed, and the trench is not a cartoon monster pit. It's a harsh ecosystem where life tends to be small, specialized, and built for pressure. The scary part is not a giant fish. The scary part is how little we can see and how much we can still hear. So let me ask you something today. Why are we so desperate to find monsters in the dark when the truth of shifting ice and cracking earth is already powerful enough? And if NOAA has explained Bloop and Julia with icequakes, do you think there's still a sound out there that science hasn't named yet? Because here's what makes the 2015 tapes feel different. If it's not monsters, and it's not just ice, then what was the real reason scientists felt that chill in their stomach when they played back the Mariana Trench recordings? The real panic. The death of the silent abyss. Because here's the part that doesn't trend on TikTok. The real reason those 2015 tapes felt eerie wasn't a monster hiding in the trench, it was the sound of us. When NOAA finally pulled up the hydrophone and started replaying what Challenger Deep had been hearing for weeks, the team expected a deep-sea soundscape that felt ancient. Earthquakes, typhoons, maybe a distant whale call, the kind of natural soundtrack that makes you feel small in a good way. Instead, the abyss sounded crowded. Not crowded with creatures, crowded with human noise, humming in the background like a city you can't turn off. Ship propellers, the low, steady grind of engines, mechanical tones that don't belong to nature, but they travel through water like they were built for it. And that is the panic people misunderstand. The panic wasn't about what was down there. It was about the fact that we have polluted the last quiet place on Earth without even setting foot in it. Think about the symbolism for a second. Humans have only visited the deepest trench a handful of times, but our noise got there early. That means the bottom of the world isn't protected by depth. It's not protected by darkness. The ocean doesn't work like a vault. It works like a speaker system. And this is what scientists call acoustic intrusion, which is a fancy term for something you already understand. When the background gets loud enough, it starts drowning out the important signals. Down in the deep sea, sound is not decoration. Sound is survival. Whales use it to communicate, to find mates, to coordinate, and to avoid threats. In the dark ocean, sound is basically vision. Fish and deep-sea animals use vibrations to hunt, to navigate, to sense what's near them. So when you flood that world with constant engine noise and sonar, you don't just annoy them. You can mask their calls, confuse their movement, and shrink the distance they can hear each other. It's like trying to whisper to a friend in a nightclub that never closes. And here's the twist that hits hardest. We spent decades imagining the deepest ocean as a silent cathedral. But the 2015 recordings suggested it's more like a basement that still hears the upstairs party. Even a ship passing miles above can show up down there because water is brutally efficient at carrying low-frequency sound. So, if you were a creature of the dark, would you survive in a world that never stops screaming? And is there anywhere left on this planet where we can experience true silence without leaving Earth? That's why this is bigger than a spooky story. The death of the silent abyss is not just poetic, it's a warning label. If human noise can reach the deepest trench, it can reach anywhere, and it can change behavior in ways we don't fully measure yet. But here's the good news, and it matters. Unlike plastic or oil, noise is one of the few pollutants we can reduce fast. We can slow ships down in sensitive areas. We can redesign propellers to reduce cavitation, that crackling bubble noise that travels far. We can route traffic away from migration corridors. We can limit the loudest sonar and blasting in key habitats. We can treat underwater sound like a resource, not an unlimited dumping ground. So what do we do to protect the deep ocean's acoustic sanctuary before it becomes a permanent echo of our machines? Because once you hear that the Mariana Trench is noisy, the mystery isn't what's hiding down there. The real mystery is how long it will stay livable for the things that were there first. And that's the eerie part. The deepest trench on Earth isn't a sealed tomb, it's a recorder. Mariana Trench captures whale calls, tectonic groans, and now, even us. The real mystery isn't what the ocean is hiding, but what we're drowning out. If this changed how you see the deep ocean, like and subscribe. Does the abyss belong to whales, or have we claimed it with noise? And if silence is a resource, who's protecting it? Tell us below.